investigating PDF malware. So how I got started, I was sitting at work one day and one of my coworkers sent out an email about where you can download free books. How many of you had an email like that? A couple of you? I was curious what would motivate someone to provide downloads of free books, most of which are probably under some sort of copyright. And as a result, I decided to investigate it. And the conclusion that I came to was there's really only one reason to allow for downloading books that are owned by someone else for free. And that's because the people that are doing that are actually getting something out of it. And the way that they get something out of it is through malware. So essentially, the majority of those kinds of things are part of larger criminal enterprises, and they're using these things and other things, and they're also used in conjunction with phishing to be able to get access to your computer and the things that you have access to. So first of all, we should talk about what a PDF is. A PDF is a file format representing documents in a manner independent of the application's software, hardware, and operating system used to create them, and of the output device on which they are to be displayed or printed, according to the docs. So essentially, PDF is a growth from PostScript that is a language designed to identify the locations for objects on a page and place them there in a way that is cross-platform. So why malware on PDFs? Well, cross-platform is a really great idea. Anything you can write once and it works on every platform, that's really helpful. Plus, it's everywhere. So how does PDF work in general? I'd like to go through a little bit of history here. The format for PDF was originally called Camelot, developed by Adobe, and it was first introduced in 1993. Then in 1996, they added a couple of extra features, including passwords, encryption, objects, and links. And it defined a more structured format than most PostScript language programs, and especially when it started including hypertext links, they're not part of the page themselves, but they end up being useful for interactive kinds of viewing. How many of you have clicked on an HTTP or HTTPS link in a PDF document? A couple of you. It's kind of evil, right? It's helpful, but it's a little bit evil. In 1996, they introduced version 1.2, where they had forms that were added to PDFs. How many of you filled out a PDF form? Maybe for tax documents, probably a lot of you. Movies and sounds. We're going a little bit off the rails here, right? Next, in 2000, they added JavaScript and embedded file streams. How many of you hackers are excited about those two things? Everybody better be raising your hands. Those are like great tools to get into things. Then finally, in 2001, they added JBig2, which is a compression for images. JBig2 decode has some serious issues in PDF documents, so that's a great place to do some exploits. We're going to skip a couple different versions and then move to version 1.7. They added encryption, a different kind of encryption in version 1.7. The encryption that was added in 1.1 was based on MD5 and RC4. Those of you who are crypto people know that's not a very good idea. So they added AES encryption in 2008, and then they discovered how flawed it was and fixed it in 2011. There's actually, I believe, a specification for version 1.7, and I don't have a lot of information about that. There are two standards for PDF documents. You have the Adobe standard and the ISO standard. The ISO standard is generally the one that is included in almost every single PDF document that you have ever seen. The Adobe standard simply adds content to that. So they generally refer to those as Adobe extensions on top of the ISO standard. All right, in the end, what does an attacker want? I think that an attacker wants to execute shellcode. right? They want to gain access to your device when they're trying to attack your computer through a PDF. So what they really want to do is be able to get some code in that document and execute it. So the way that I like to look at this, ever since I was a kid, whenever I was playing those games where I would play a maze, I loved to start at the end. Start from where the solution is already apparent and work my way backwards. If you start from the beginning, oftentimes all the forks seem really convoluted and hard to understand. But if you start from the place where you know you need to get to, it seems easier to me. So I want to talk about some of the fundamentals of how a PDF is built. How many of you have looked at a PDF in some sort of editor before? Okay, so maybe not too new. This is what a PDF looks like. That's probably really small for some of you in the back. I'll zoom in just a minute. But essentially, it's mostly binary data. And reading binary data is hard for people. It's really easy for computers, but it's hard for people. So let's talk about the different components that are in PDF documents. First, we have a header. Beginning in PDF version 1.4, the file header can actually be overridden by a version entry in the document catalog, so that's not terribly helpful. But this is what a header looks like. I don't know if you can see that over there. Am I pointing to the right thing? Where it has the %PDF 1.3 and then some things after that. That's generally the version that you've got. If you have that kind of PDF header, that's how you know what kind of a PDF document that you have. Unless, of course, it's overridden in the dictionary that tells you the version, thanks to PDF 1.4. There are other ways to do PDF headers. Turns out that the PDF header doesn't have to be right at the top. It can be in the first 1,000 bytes. Chances are, if you have a PDF document that looks like this, instead of the default one that I was showing you before, it's probably got malware in it. There aren't a whole lot of PDF tools that inject content into PDF documents before the header. And that's because it's not very helpful to do that. You can, but it's not very helpful to do that. Then once the document has scanned the header, the next thing that it goes for is the trailer, which is at the end of the document. The trailer sets up the object root, which we're going to talk about a little bit more. And the data after the trailer is also probably bad. If you have anything that's injected into the document after the trailer declaration, it's probably not a good thing, and the document should be suspect for any kind of malware. And the trailer sets up a cross-reference to object locations by character position in the document, and the cross-reference table is a map to all the items in the file by showing you the root element. So right here we've got this is the end of a PDF document that I was experimenting with. You see a bunch of lines of code, and then you have the trailer, the little cross-reference table, and then starting the cross-reference, this is the object that you should go to, and then the EOF declaration. Anything after that is probably bad. There's not a real good reason for you to include items after that unless you're building something for our Hackers Challenge, which there may or may not be, I don't know. So once you've established the header and the footer, you should have a pretty good idea of where the bounds of the document are, what version of the PDF standard you are adhering to. So the next thing that we need to get into is the root element. So the PDF document itself is a collection of objects under the root element. And all of the objects in a PDF document descend from that root element through one path or another. And essentially, it's a tree structure. I guess we do have some fake trees in here today, but we don't have any real trees to look at. This is just a sample of what a tree looks like. Some of you are probably familiar with that. You're probably familiar with the data structures for trees as well. So there is a single base object inside of a PDF document, and everything comes off of that. The base object is usually some sort of dictionary tree that allows you to have some cross-reference mapping to other objects, inserting pages and other things. So documents or objects that are embedded inside of PDF documents. Some of you who have used PDF documents are probably familiar with things like texts. and fonts, images, forms, which is kind of nasty, JavaScript, which is really exciting for hackers, files, and then PDF documents. Yes, you can inject a PDF document into a PDF document. All of those things can be embedded into a PDF document. I think that's kind of meta when you can inject a PDF document into a PDF document. So you've got a tree inside of a tree. Fortunately, though, it appears that the language standard does not allow you to inject a PDF document into a PDF document into a PDF document. So you only have to go 2 layers deep to just try and search through those things. Once you've got the basic idea of how the tree structure works and the methods of interacting with the different objects inside of the tree structure, which we'll probably talk about a little bit more, for an attacker, what they really want to do to execute their shellcode is create some sort of heap spray or NOP sled or something of that nature where they get through enough of your randomly distributed memory to have a location pointer that points to their shellcode and execute their shellcode. For those of you who are unfamiliar with shellcode, give you a quick example. How many of you played the game Candyland? You get that you move forward 2 spaces or something. The NOP sled is essentially something that says move forward 1 space, move forward 1 space, move forward 1 space over and over and over again until you get to Lord Licorice or wherever they're trying to get to you to. Being able to do that is really exciting if you're trying to compromise a machine. It's not so great if you're trying to be safe. And there are a lot of functionality and features built into modern applications to try and prevent attackers from being able to create the NOP sled and other things like that. But attackers are getting creative in the ways that they're making their no-ops in these things. And so it's not necessarily a simple task to be able to identify this section of a document happens to be a NOP sled and this is the shellcode until you get into the code. Some of the more simple versions of software that is injected into PDF documents from malware are very easy to detect because they have a clear pattern of null operations in them. And then all of those things, of course, can be encoded and encrypted, which we're going to talk about in just a minute. So let's talk a little bit about the different kinds of objects that are inside PDF documents. The first object that you can have in a PDF document is the object itself. And then end object, you can have a stream and end stream. Those are the barriers around a stream. The crossref, the trailer, the start crossref, pages, you've probably seen those in PDF documents. Encrypt allows you to encrypt the contents. The object stream, which allows you to add all kinds of objects and files. JS and JavaScript are both JavaScript objects. AA and open action are objects that execute when the document is opened. Acroform is for form content. JBig2 decode is content for compression of images. Rich media is for sounds and videos, and then I'm not even familiar with launch. Embedded files allows you to add files in there, and then XFA and colors. So those are, I think, a pretty good list of the objects that are found inside of PDF documents. So the basic object in a PDF document looks a little bit like this. You have the object number and the object reference. You have the length of the dictionary. You have a stream, which will be a byte stream. In this case, it's just a stream that indicates that we're going to be printing out some text. There's a font and a size in there, and then the 100-700 is the position of the text on the page. In this case, this byte sequence even has hello world in plain text. Now, that's great, and if you're reading a PDF document, it's really exciting to be able to see plain text and say, I know what that's going to be printing out. If you could read the JavaScript up front, you'd probably be really good at examining PDF documents. The challenge with that is that it's usually not that simple. In fact, I don't know of a way for you to create this except by doing it manually, because most of the tools that you would create a PDF document with apply what are called filters. I believe that there are 10 different kinds of filters. These are all the ones that I have been able to find. The most common one that I know of inside the PDF structure is the flate decode. If you do LZW compression, like JPEG-based compression, then you'll have that one as well. But any one of those things can be used as a filter on top of the object stream that you have inside of your document. All of those filters have different effects, and it's hard to parse through them unless you use that particular filter. So it's not as simple as adding a single signature for some of these items of PDF malware. So here's an example of an item with the ASCII 85 decode filter. How many of you can read that? Great, so I'm not alone. That's really hard to read. And being able to decrypt that requires you to apply that filter. It gets worse though, if you're trying to do this, because someone injecting malware into your document can actually nest or cascade these filters on a number of levels. And so this particular example uses ASCII hex decoding and ASCII 85 decoding to be able to read that content. There's also encryption inside of the strings that are contained inside a PDF document. So a document that is encrypted will have the strings inside of it encrypted, but the objects will not be encrypted. So when you look at an object, you'll see this is the object table. You'll say this is object number 8. This is the start. This is the end. It's an action. It has a URL, and the URL is this thing, which I can't read without decoding. So all of those things contribute to a little bit of difficulty that we have in being able to identify and address malware in PDF documents. So of the objects that are in the PDF language, the ones that I think are the most dangerous are these ones here in red, especially the JS and JavaScript, because that's the JavaScript scripting language, which can do a lot of things when it's enabled. And then AA and open action, open by default, and then embedded file and XFA also are very dangerous. The acroform, JBIG to decode, and rich media can be used to supplement some of that content, but they're a little bit harder to exploit. So when you're looking at a PDF document, if you can identify that some of these things are in there, that should raise your alert level a little bit. If you notice that you have a PDF document that has JS and JavaScript and AA and open action in it, beware. I can't think of a reason for you to have all of those in a regular PDF document at all. It's possible, but I can't think of one. And in the end, all of these things can be nefarious, and all of these things can be benign. You have to be able to understand the content of the document that you're working on. If someone is sending you an invoice, I would question the need for having JavaScript in an invoice. I would question the need for having something open as soon as you open the document, executing some code when you're just viewing an invoice. So this is what an open action object looks like. You have your object. This is object number 1. It's a catalog. It has all these outlines and some pages, and then an open action, which refers to object number 8. When you have that, as soon as the document opens, it probably opens object number 1, which might be the root object. In this case, it probably is. And then it fires off a couple of different pages, and then executes the open action. So all of these things are parts of the PDF structure, and this PDF structure allows some of our attackers to be able to inject items into our PDF documents. So at this point, I want to talk a little bit about some of the tools that we have to work with PDF documents. How many of you have seen work by any one of these 3 people? A couple of you. So Didier Stevens, a Belgian researcher, has done some incredible work on PDF malware and identifying it and being able to execute those kinds of things. If you haven't seen his work and you're interested in PDF malware and understanding how that affects you, I would recommend that you go to his site. It's blog.didierstevens.com. and he's got some incredible tools there. The two that I find most useful are PDF ID and PDF Parser. PDF ID is a tool that you can use. You run it as a Python script against your PDF documents, and it will identify the basic objects inside of the PDF document to give you kind of an idea of how risky that document is. And as you run that tool, if you run it on a lot of PDF documents, you'll start to recognize some patterns. You'll start to recognize when certain things are applied together, they're far more likely to be dangerous than when they're apart. For example, if you have JavaScript and an open action together, those are likely to be some sort of malware. Then he also has the PDF Parser, and PDF Parser is a much more in-depth tool. PDF ID is very simple, very, very simple. It doesn't do a lot of functions inside the PDF document, and the reason for that is because the more functionality you add to your tool, examining PDF documents that probably have or could have malware in them, the more likely you are to have some sort of vulnerability included in that PDF reader. As a result, PDF ID is very small, it's very succinct, and it generally does not include a lot of features that you would use as far as debugging or deep investigation into those documents. That's both a good thing and a bad thing, but mostly a good thing because it can be used in conjunction with PDF Parser. PDF Parser is a more sophisticated tool as far as investigating the contents of PDF documents. When you use PDF Parser, you have the ability to follow an object stream, object by object, decode all of the filters, filter by filter, and extract the contents of individual objects as if they were plain text. How many of you think that's an awesome tool? I do. I think that's incredibly useful. If you want to know what kind of JavaScript someone has injected into a PDF document that's used as malware and be able to come up with patterns to prevent that from escaping your network or installing ransomware on someone's computer or some sort of backdoor shell or something like that, being able to identify that is really helpful. And it's really hard to do that when a PDF document has encrypted streams that have random white space and can have any number of filters applied in any way. But the PDF Parser allows you to do that. Also, the PDF ID tool has a -D option, which I highlighted here. That removes the JavaScript and open action features of the document and gives you a new PDF document without those. Just removing those things basically removes most of the possibility of vulnerability in that document. So if you're trying to remove PDF vulnerabilities in your environment and you have the ability to, say, script PDF documents that are incoming in email and you want to run PDF ID -D, then all of those PDF documents can be modified to remove the items that appear immediately on opening the document, which is really cool. Being able to do that in a simple command is great. I'd also like to request if anyone here is really good at C code, I'm working on a faster version of that sort of thing, writing it in C, because PDF ID is in Python, and although Python is a great language, it's not nearly as fast as C. So what I'd like to do is, if anyone has some interest in that or some C development skills, come talk to me after this talk, and I would love to discuss the possibility of you helping out in building that tool. I want to build a tool that allows us to flush through really large PDF documents in a very short time frame, and as we do that, remove these kinds of things that are the most dangerous without modifying the document in a way that prevents people from being able to use it in a functional manner. So anyway, with those two tools, the PDF ID tool and the PDF Parser tool, you have the ability to identify very quickly on a relative scale using PDF ID, how risky is this document? If you are an IT manager or a security manager and someone sends you a document and they're not sure if it's risky, you can download PDF ID. It is open source. There's a link to GitHub that I did not post here, but comes from Didier Stevens' site. And you can download that code yourself and run it yourself and find out how risky that is. If you find things that include JavaScript or open actions, that's probably not so great, and you might want to remove those items. The PDF parser is for more advanced things, and if you start digging into that, you will start to identify how someone is getting shellcode onto your systems. It's worth noting that executing shellcode through a PDF document is not an easy thing to do, simply because there are lots of different PDF readers out there, and most of the exploits that are included in PDF documents are actually version specific or software specific. How many of you open PDF documents with the Adobe Acrobat Reader? Okay. How many of you open PDF documents with a different reader? How many of you use the Mac preview thing? Okay. How many of you use your browser with the built-in Firefox, Chrome, whatever? So all of those things have different code bases, and having different code bases means that a different developer came up with that, and hopefully they got all of the things that they were supposed to. But there are different vulnerabilities for different software applications that are used to open these things. When you have those different pieces of software, it's really hard to determine whether or not you will be vulnerable to that. A lot of those things are vulnerabilities with older versions of PDF readers. So if you haven't seen the talk that I gave yet on updates, you should watch that and then go update your PDF readers. Making sure that your software is up to date is also a really important factor in preventing PDF malware. Then the next piece of software is by Jose Miguel Esparza, and he wrote PPDF. And to my knowledge, there isn't any functionality inside that software that allows you to be able to remove undesirable pieces of the document or to defang them, so to speak. But it does give you a really good view inside the PDF document. And it's very similar to the PDF parser. A lot of the things that it returns are very similar simply because they are reading the same format and the same kinds of things are dangerous. The PPDF file also includes the software that allows you to kind of assign a vulnerability scale to documents, which could be really helpful if you're trying to determine how risky is this and you don't want to do the investigation yourself. If you just want to script it and have a certain number that says this is risky enough to throw out or whatever, that might be the thing for you. I guess I also failed to mention the Didier Stevens PDF parser has the ability for you to plug in add-ons that could do that same kind of thing for you automatically. There have been a number of add-ons that have been released for that, so that's very helpful as well. And then I had a question today as I was preparing for this talk about what do you do if you're sending out a PDF document and you want to extract all of the metadata out of that. It's not necessarily a malware-related question, but it is a PDF-related question. And so if you want to do that, you should probably get PDF Redact Tools by Micah Lee. And PDF Redact Tools essentially draws the screen for the PDF document, takes a JPEG or PNG snapshot of it, then recodes that back into a PDF without any of the metadata at all, which is also very cool. All right, so here's an example of the output of PPDF. You've got the file, the hashes of the document, the size, the version, whether or not it's a binary file, which is almost always true, or whether or not it's encrypted, how many objects and streams are in there, and errors, which a lot of times errors can indicate whether or not your document is nefarious. Then we've got a catalog, which has all the objects that are inside of that, all the different objects and where they're referenced. Then your streams, and then down here, the more dangerous stuff, the objects with JavaScript code, suspicious elements, the form and the XFA, and some heap corruption, which happens to have a CVE next to it. If you get those kinds of things out of your scan trying to look at PDF documents, that's probably bad. It would be worth also looking at that in that CVE or whatever CVE that might pull up. And if you find that your system is vulnerable to that, you either need to not have people opening that document, or you need to make sure that your software is patched so that it's not vulnerable to that thing. All right, and then here's a highlighted view of that same thing. If you're right here, seeing errors is always a bad thing. If you have a PDF document that crashes every time you open it, chances are that's not very good. How many of you saw the pilot for the show, Mr. Robot? How many of you saw the segment of the show where the gentleman handed out a CD for his whatever, and someone put that into their computer and they said, "It doesn't matter what I do, it keeps crashing." As soon as I heard that, I thought, oh no, I know what that is. If you have software that crashes, that's an unhandled exception. Hackers love unhandled exceptions because that means that there's nothing preventing them from being able to jam something into memory and hopefully execute shellcode. It's usually a trick to get past that, but being able to know that there is an unhandled exception is very, very helpful. So I've got a couple minutes before we need to have some questions. What I'd like to do is see if I can show some live usage of the PDF ID tool, if that's okay. All right. Okay, here we are. So here are my demos directory. Is that better? Can you hear me now? I've got a couple of files that are included in that directory. These PDF documents that are included in here are PDF documents that I downloaded from this free book site because I thought that would be fun. So inside of here, we've got a book on 802.11 wireless networks, the definitive guide, 2nd edition. How many of you would like to read that? Maybe a good book, right? Photoshop CS6 Bible or Lightroom and all that, or advanced penetration testing. Let's go ahead and try the advanced penetration testing. It takes just a minute to load. Like I said, it's Python, so it's doing a great job, but Python's not as fast as compiled code. All right, so there are our results, and let's see what we have here. I haven't done this on this document before. So we've got the PDF header. It says version 1.6. There's 7,374 objects and 7,374 end objects. That's probably good because they're the same number. The streams are also the same. We've got cross-reference tables, trailers, 414 pages in the document, 56 object streams, but you'll notice down here, AA has a number 1. And if you notice a little bit down farther, Acroform has a number 1. This document probably has malware in it. So that's our first document. Let's try another one. Thank you, tab complete. That would be really hard to type without being able to see it. All right, that one was a lot faster. So we have the same number of objects and end objects and streams as well. This is PDF version 1.4. And inside of here, we have an encrypt object and a JS object. So there may be malware in here, but you'll notice that there's no AA or open action. So it probably doesn't fire the second you open the document. That's probably a good thing. All right, what other ones do we have? let's try the Adobe Photoshop CS6 Bible. Hopefully the demo gods will be very nice to me and we can find one that has some really interesting stuff in it. Apparently it's a really big book. And JT, I think I need some more CPU, so if you can have some of that sent up, that'd be great. Maybe we should open it up for questions while we're waiting for this. Does anyone have a question they'd like to ask? Right here. It could be all right, but the presence of both of those things together, if those two things are linked up and the open action calls the acroform and the acroform itself is the exploit, then not so much. So now that you bring that up, let's talk about a document that I think is a little bit more interesting. The Adobe Photoshop CS6 Bible from the free book site has inside of this 1,122 pages, but it has 5 JavaScript objects, 25 AA, and 1 open action items in there. So when you open this PDF document, 26 things fire. If it's just a book on Adobe Photoshop CS6, why would you need that? I don't know. And in the end, the reality is that you'll need to investigate these documents one-on-one. You'll need to look into them individually to be able to tell, is it malware or not? Of the documents that we've looked at today, this one seems like the most obvious one to include malware because there are lots of open actions and lots of AA records. All of those things, all those objects are potentially dangerous. The higher the number, the more likely they are to be dangerous. You can also see that there's a difference between the objects that are open and the objects that are ended. That's probably also not a very good thing. And then let's run this with the -D. So essentially what this does is it does a regular expression replacement, changes open action with the capital O and the capital A to everything is the wrong case. And the PDF document reader just says, I don't know what that is, and moves on. Pretty cool idea. While we're waiting for that, JT, you had a question? Okay, so the question is whether I have seen more malware that is like PDF-based attached malware or links inside the email instead. I would say that it's probably more common to see links inside the email because There are a couple of things that are really great about links inside an email, and that is, well, number one, people click on them all the time. And number two, you can control what's on the other end, and you can update it, or you can deliver different content based on a lot of different features that you might be able to detect. When you send out a PDF document to someone, you're really hoping that they have something that you already have code for. So, if you have a PDF malware specimen that's really, really good, but it works on Windows with Acrobat Reader 7, that's awesome if the person that you're sending it to has Acrobat Reader 7. If they don't, then that's not so great. And so, if I were trying to create the more sophisticated phishing malware kind of thing, it might even be beneficial to give people a link to a PDF document on a website. Does that answer your question, JT? All right. Who else has a question? We're waiting for this to defang the document. Yes?
A couple of comments. One is the launch command actually launches an external program. Someone thought that was a good idea.
Yeah. So a lot of these things, the question was about, well, I got a comment about the launch object that launches an external program. A lot of the features in the PDF realm seem questionable and tenable at best.
Put in, for example, for school teachers where they want to have a chapter, talk about something, then you actually launch an external demo program sometime, like a something textbook or something. So it has not too much malware to do that, because it was like gone off and thought that was a good idea.
Yeah, so a lot of these things inside of PDF documents were added for good reasons. It's really cool to be able to do things with a full-featured programming language like JavaScript, as opposed to just the PDF language itself. However, the moment you open up a full-featured language like JavaScript, you allow hackers to do things like buffer overflows. And when they can do buffer overflows, they can do NOP sleds, and they can inject shellcode, and they can execute that whenever they get to some sort of unhandled exception. And the same kind of thing applies for that. The PDF specification also allows for you to embed files in there and to save the files out, but somehow, some way, someone decided that saving out executable files is not a good idea. So they disallowed that. So at least we have some hope in that. Yes? Right, and so the comment is that some of the PDFs that he has seen actually try to open up jar files, and the end result of that is there's no way for me to tell you for sure whether that's bad or not. It could be great for your environment, but the PDF specification allows for that, and that's the real danger. The PDF specification allows for a lot of incredible features, but almost all of those incredible features, starting with version 1.1, were really great for attackers. Being able to inject full JavaScript stuff, being able to use forms to inject things, being able to embed full files and save them out to the disk. And some of the advancements in PDF readers lately have been, working on mitigating those kinds of things. By the way, if you haven't updated your PDF reader in the last little bit, you might want to, because there have been a lot of vulnerabilities for PDFs and Flash in the last little bit. Other questions? Okay, well, let's take a look at the results from our removal of those things. So we had one open action that got replaced, a couple JavaScript things, and then another set of AA, which is another kind of open action, and then some JavaScript. So at the end of that, it also gives you the PDF header results and the object count and everything for that particular document. And it shows you the counts for the things before that. It created a new document. Inside there, where is it? Oh, .disarmed. So if we do a PDF ID on the Adobe Photoshop CS6 .disarmed. This will take just a minute. And it will show that those things have gone away, which will be really helpful. Do we have any other questions? We got like 2 minutes left. All right. I'll stand up here and talk while we're waiting for this. In the end, I found that PDF malware is a very interesting topic for me. I liked researching it. If you want to know more about this, the research done by some of the people that have created these tools is incredible. Didier Stevens has a number of videos that are available on YouTube. He's given talks at security conferences around the world. If you want to learn how to use his tools, he's much better at teaching them than I am. And you can learn some great things with that. He has found a lot of things, and he regularly updates his tools as well. So that's really helpful. And then there have also been a couple talks, I think a DEF CON talk about PPDF. Yes? Some sample malicious PDFs. Google free ebooks. That'll be a really quick way to get some sample ones. And you know, I don't know. I'm pretty sure that Didier Stevens has a number of things. He also he has another tool that I didn't mention in this talk, and he has a tool that allows you to create your own. And hopefully you'll use that for good. But that tool allows you to inject content into PDF documents, and being able to do that, I think, is helpful in being able to understand how that affects PDF documents, and hopefully helps you to be able to identify those kinds of things inside of your PDF documents. Does that answer your question as far as where you can get those and what you should do about it? Maybe. Yeah, I mean, I don't have a repository that I can help with that, which is probably okay because I don't want to distribute malware. All right, so if you look at the results of the PDF ID now, it looks a whole lot better. All those objects that can be seen as negative have disappeared. And if that did not negatively impact the document in any way, if you can still read all of the things that you want, why not? There's nothing that prevents you from being able to do that. If you can do that across your organization for every PDF coming into your email, then you solve that problem of people emailing you with PDFs of this is an invoice for such and such to your accounting department, and they open it up and now all of your accounting files are ransomware or whatever. So that's a great tool for that. The other tools that I listed are also very helpful. Any other questions before we finish up? Okay, thank you very much.